NASA's Surveyor 5 was the fifth spacecraft in the Surveyor series that was launched to the Moon to study its surface and gather data on the lunar environment. It was launched on September 8, 1967, atop an Atlas-Centaur rocket, and successfully landed on the Moon's Mare Tranquillitatis on September 11, 1967. This mission was one of the most successful lunar landings of its time, and it helped pave the way for future manned missions to the Moon. The primary objective of Surveyor 5 was to collect data on the lunar soil, rocks, and other geological features. The spacecraft was equipped with a series of scientific instruments, including a television camera, a soil mechanics surface sampler, a surface alpha scattering instrument, and a magnetometer. These instruments allowed the spacecraft to analyze the physical properties and chemical composition of the lunar surface. One of the most significant achievements of Surveyor 5 was its ability to perform an in situ analysis of the lunar soil. The spacecraft's soil mechanics surface sampler successfully scooped up soil samples from the surface of the Moon, which were then analyzed by the onboard alpha scattering instrument. The results of these analyses revealed the presence of various elements and compounds in the lunar soil, including aluminum, silicon, iron, and titanium. Another significant accomplishment of Surveyor 5 was its ability to transmit large amounts of data back to Earth. The spacecraft was equipped with a high-gain antenna that allowed it to send data directly to Earth. This data included thousands of photographs of the lunar surface, as well as data on the Moon's magnetic field and radiation environment. Surveyor 5 was also able to perform a series of engineering tests that helped pave the way for future lunar missions. For example, the spacecraft's landing gear and rocket engines were tested to ensure that they could withstand the rigors of a lunar landing and takeoff. These tests provided valuable information that was used to design and build the lunar landers that were used in the Apollo program. The success of Surveyor 5 paved the way for future missions to the Moon. The data collected by the spacecraft helped scientists better understand the lunar environment and the challenges that would need to be overcome in order to send humans to the Moon. This information was used to design and build the Apollo spacecraft, which successfully landed humans on the Moon just a few years later. The Surveyor program was also instrumental in advancing the field of robotic exploration. Prior to the Surveyor missions, there was little experience in operating robotic spacecraft on another planetary body. The success of the Surveyor program helped pave the way for future robotic missions to Mars, Venus, and other planets. Surveyor 5 was the last spacecraft in the Surveyor series to successfully land on the Moon. While later Surveyor missions experienced technical difficulties and failures, Surveyor 5 demonstrated the viability of lunar exploration using robotic spacecraft. Its success paved the way for future missions to the Moon and other planets. The data collected by Surveyor 5 and other Surveyor missions continues to be studied by scientists today. The samples of lunar soil collected by the spacecraft are still being analyzed, and new discoveries are still being made. The data collected by the spacecraft has also been used to design new missions to the Moon and other planetary bodies. In addition to its scientific accomplishments, Surveyor 5 also helped to inspire a generation of scientists and engineers. The success of the Surveyor program demonstrated that it was possible to explore the solar system using robotic spacecraft, and it helped to lay the foundation for future missions of exploration. The Surveyor program was also significant in the context of the Cold War. At a time when the United States and the Soviet Union were engaged in a fierce competition for technological and military superiority, the success of the Surveyor program demonstrated about the impact of the Surveyor program on space exploration. The Surveyor program had a significant impact on space exploration, both in the United States and around the world. The success of the Surveyor missions demonstrated that it was possible to explore the Moon and other planetary bodies using robotic spacecraft, which paved the way for future missions of exploration. One of the most significant impacts of the Surveyor program was its role in advancing the field of robotics. Prior to the Surveyor missions, there was little experience in operating robotic spacecraft on another planetary body. The success of the Surveyor program helped to establish the feasibility of robotic exploration and provided valuable lessons that were applied to future missions to other planets. The Surveyor program also played a critical role in paving the way for the Apollo program, which successfully landed humans on the Moon. The data collected by the Surveyor spacecraft helped scientists better understand the lunar environment and the challenges that would need to be overcome in order to send humans to the Moon. This information was used to design and build the Apollo spacecraft, which relied heavily on the technology and expertise developed during the Surveyor program. The success of the Surveyor program also had a significant impact on public perception and support for space exploration. The images and data transmitted back to Earth by the Surveyor spacecraft captivated the public imagination and helped to build support for continued exploration of the Moon and other planets. The success of the Surveyor program helped to establish NASA as a leading force in space exploration and inspired a generation of scientists and engineers. The data collected by the Surveyor spacecraft also provided valuable scientific insights into the lunar environment. The soil samples collected by the spacecraft are still being analyzed today, and new discoveries are still being made. The data collected by the spacecraft has also been used to design new missions to the Moon and other planetary bodies, providing valuable information for future explorers. The Surveyor program also had a significant impact on international cooperation in space exploration. The success of the program demonstrated the importance of international collaboration in advancing scientific knowledge and exploring the unknown. The lessons learned from the Surveyor program helped pave the way for future international partnerships in space exploration. The Surveyor program also had important implications for the field of planetary science. The data collected by the Surveyor spacecraft helped to advance our understanding of the geology, chemistry, and physics of the Moon. The success of the Surveyor program paved the way for future missions to other planetary bodies, including Mars, Venus, and beyond. The legacy of the Surveyor program continues to be felt today, both in the United States and around the world. The success of the program helped to establish NASA as a leading force in space exploration and inspired a generation of scientists and engineers. The data collected by the Surveyor spacecraft continues to provide valuable scientific insights into the lunar environment and is still being studied today. The lessons learned from the Surveyor program continue to guide and inform future missions of exploration, paving the way for new discoveries and advancements in space science and technology. Surveyor 5 was the fifth mission in the Surveyor program and was launched on September 8, 1967, from Cape Canaveral, Florida. The spacecraft was designed to land on the Moon's surface and collect data on the lunar environment. Surveyor 5 was the first spacecraft to use a new landing system that allowed it to land more accurately and gently on the Moon's surface. After a journey of approximately 4 days, Surveyor 5 successfully landed on the Moon on September 11, 1967. The spacecraft was equipped with a range of scientific instruments, including a soil scoop, a seismometer, and a surface sampler. The spacecraft also carried a camera that was used to capture images of the lunar surface. One of the most significant discoveries made by Surveyor 5 was the composition of the lunar soil. The spacecraft's soil scoop was able to collect samples of the lunar soil, which were analyzed on board the spacecraft and transmitted back to Earth. The data collected by Surveyor 5 helped scientists better understand the composition of the lunar soil and paved the way for future studies of the Moon's geology and chemistry. The seismometer on board Surveyor 5 also provided valuable data on the structure and composition of the Moon. The instrument was used to detect seismic activity on the Moon, which helped scientists better understand the internal structure of the Moon and its composition. The camera on board Surveyor 5 also captured a series of images of the lunar surface. These images provided valuable information on the surface features of the Moon and helped scientists better understand the geological history of the lunar surface. Surveyor 5 also demonstrated the effectiveness of the new landing system that was used in the mission. The spacecraft was able to land more accurately and gently on the lunar surface than previous Surveyor missions, which helped to minimize the risk of damage to the spacecraft and improve the quality of the data collected. The success of Surveyor 5 had a significant impact on future missions to the Moon and other planetary bodies. The data collected by the spacecraft provided valuable insights into the lunar environment and helped to establish the feasibility of robotic exploration of other planetary bodies. The lessons learned from the mission were applied to future missions, including the Apollo program, which successfully landed humans on the Moon. The legacy of Surveyor 5 continues to be felt today, with the data collected by the spacecraft still being studied by scientists around the world. The mission paved the way for future missions to the Moon and other planetary bodies, and the lessons learned from the mission continue to guide and inform future missions of exploration. In conclusion, Surveyor 5 was a groundbreaking mission in the Surveyor program and had a significant impact on space exploration. The data collected by the spacecraft provided valuable insights into the lunar environment and helped to establish the feasibility of robotic exploration of other planetary bodies. The success of Surveyor 5 paved the way for future missions to the Moon and other planetary bodies, and the lessons learned from the mission continue to guide and inform future missions of exploration. The legacy of Surveyor 5 will continue to be felt for years to come, inspiring new discoveries and advancements in space science and technology.